If you thought Houdini 18 was fun, let's check out Houdini 19 and the fun that it brings. Match size. This node is awesome, definitely one of my most used nodes in Houdini. And now in Houdini 19, it got some seriously cool upgrades. So let's not mess around, let's jump into Houdini and check it out. At its core, this node resizes and adjusts geometry based on reference geometry. If you don't feed in specific secondary geometry, it'll use a self-contained bounding box. Something I use this node for on a daily basis is snapping things to a certain world axis, such as the y-axis. Set the match size to min, and now I can freely scale my box and stay on the ground. Now in Houdini 19, we have these really cool offset sliders. So if we want our box slightly off the ground, it's a simple slider. We no longer need to add an additional transform node. Another cool use case for this node is when you have geometry in your scene that is not at the world origin, like my pig head over here. Now let's say I want to do some modeling to my pig head. If I wanted to use something like a clip or a mirror, it's difficult to find the correct location in space. So instead of fiddling with that, I can drop down a match size to center my geometry and be sure to stash the transform. This will save my position data in an X-form attribute. Now I can do some fun modeling like clipping and mirroring because it's right at the world origin. I can also do some other fun modeling techniques if I feel like it. When I'm done, I can use a transform by attribute node. I can check invert transform, and just like that, my pig head is back on its stand with all its newly modified additions. In Houdini 19, we can also now specify groups that we want to use. So in this scene, I have this spectacular wall that I modeled. The modeler only included a single group for me to work with, and that is where I need to place Flippy. Now I could certainly manually try and transform him there, or I can use the match size and check use groups to determine justification bounds and select my group in the target group field. Now Flippy is kind of in the right place. We just need to change the justification of Y to min. Let's also rotate Flippy around. Now another cool feature in this node is the scaling feature. Let's say we want Flippy to fill this space. We can have him scale along the Z-axis, and now he's fitting that group section perfectly. I'm sure you can imagine that this function has a lot of uses. With the new additions in Houdini 19, we can really easily do stacking effects. Let's take a look at how we can set this up. Here I did a very basic model of a book, which is going to be our input geometry. However, we can use whatever we want as the input geometry. I'm now going to create a for each number. This will let me repeat the same task as many times as I stipulate. So this will control how many books I create. We'll change the method from fetch input to fetch feedback. Next, we'll feed our input geometry into the for each begin. Now we want a match size. We'll feed our original geometry into the left and the for each begin on the right. So it'll use the previous book for the next book's reference geometry. We need to change the justify settings on X as our books are now on the X axis. Let's set it to be min and max. Now we can get a row of uniform books. Pretty cool, but let's add some more fun. First, let's add some random color. So we'll use a color node. We'll set the group to the outer book, which is the group I created on the book model. Next, we'll change the color type to random from attribute. Now in the seed, we'll use a small expression that'll generate a random color for each book. We'll use detail to call the detail attribute, and then we want to get the iteration attribute from the metadata block, and we'll set 0 at the end. Now we have a random color for each book that we generate. Now let's do the same thing for the sizes. So let's copy this expression as we'll use it again. Let's drop down a transform node. In the scale field, let's drop down this expression, but we're going to add a little bit more to it. First, we're going to use a random function, or rand. This will take the incoming values and it'll give each one a random number between 0 and 1. However, we'd like a little bit more control than this, so we can use a fit01 function because we know that rand is giving us a 0 to 1 attribute. And then at the end of the expression, we can specify the new values that we want to fit the 0 to 1 range to. So let's use 0.2 and 1 for the X, 0.6 and 1 for the Y, and 0.2 and 1 for the Z. And just like that, we have perfectly stacked books. Obviously, we can add a final match size at the end to place the books on the floor. Or you can even feed it the bookshelf with groups and place the books right on the shelves. You can also use the match sizes scale functions to fit the books nice and snug. The last walkthrough I want to show you is how you can very easily use this tool for procedural modeling. Here I created a procedural sofa without any expressions, and just using the match size nodes we get a fully dynamic procedural sofa. Let's take a look at how I set that up. I start with the box and I set some dimensions. Next we'll use a match size to center this and place it on the floor. Now I created another box. I'll leave it at the center at 0, 0, 0, and I'll use another match size and I'll plug my first sofa into the second input. I'll change the justify width to the second input. I'll now use the justify commands to get my second block to line up with the edge and the back of the first block. I'll use the scale parameter so that when I adjust the height of the main block, this moves accordingly. So I set just the Y scale to match that of my reference geometry. I now Boolean union these two blocks together. The reason for this is I want these to be a single unit for when I poly bevel at the very end. If I turn this off, you'll see how these are beveled separately. Boolean makes them one, and now I get a nice bevel around the outside. We'll repeat the process with another block, feeding in the first two blocks. Again, we'll use the justify commands to get it to sit in the correct place. This time we want to set the scale to fit the Z-axis so that it auto adjusts with the other pieces. We'll repeat the same thing but for the side piece. Finally, I'll add a small poly bevel, and it all adjusts really nicely. I realized though that some feet would be nice, so let's take a look at how I added those. I created a tapered tube, and then I did the same tricks as before with the second input. However, this time I made use of the offset feature, so I could offset the feet inwards just a little. This is such a useful feature. I then used a mirror to mirror these feet. I repeated the process for a few more feet, and I just adjusted the position and the justification settings to get them in the right place. Once I'd created all the feet, I merged them with the final sofa. One final match size to place it on the floor, and just like that, procedural sofa with 0 expressions. I hope you can see how incredibly powerful this node is. Houdini 19 really unlocked some amazing features on this one. I'd love to see what you use it for, so it's time to dig in and play. It's Houdini time.